So we'll actually have shirts for this thing. What a concept. I don't want to wear it right now. It smells like chemicals. I'll have to wash it. And I am getting absurdly hungry, so I'm gonna have to eat something. And I started cooking something, so that'll be good. So I need to get. Yeah. Okay. So. I need to make it so we can actually retrieve the information for the flow field and magnitude at runtime on this actual object. So it's going to be inside of the water blueprints. We're going to need a function. Yeah, let's see. The particle sim stuff, we got flow field gen. The magnitude fill radius is 16. We're supposed to be setting some variables here. We need to set our maximum water, random water speed, shore water speed. I need the actual maximum magnitude saved on this thing. So I'm going to go under saved. I'm going to need a variable here. This is going to be max flow field speed. I have to be under saved. This will be a float. Compile it. It should be a 0. Slider is not going to do anything. And once we actually generate the flow field, we're going to want to call get max speed off of it. So that's going to be get max water speed. So we need the calculated flow field. Save real flow field data. Alright, that's fine. So we'll get this and then we'll set it right here after. Let's see if it actually saves to our level and everything else. Water flow feed speed 10. Alright. Let's do it on this guy. So we have our save data. It's going to save it as a 0. So let's actually have it set as -1 to begin with, and that'll just tell us like it's uninitialized and garbage. Alright, so construct stack flow field, tick flow field. And then generate flow field on this guy, and then this one should have 10. And if we save everything and then reload the map, is it going to be 10 still? Is the question. because we had some problems with saving data and all that sort of stuff earlier, where we're just trying to save, you know, some like basic stuff. So we'll see if this actually saves. I just need to verify it, or if I need to save an actual asset. Yeah, this saved is 10, and this one is -1. Awesome, so it did actually save, which is excellent. Like this arrow that just goes into nowhere land. Alright, I'll be right back. I need to throw some food in the oven. Yeah, food does sound good, especially when you're hungry. So I need to now add the lookup functions to this water object. So this function is going to be different. I'm going to need a water object interface, I believe. This, yeah, we'll need a new blueprint interface so that we can call into this object. It's going to be water surface object. Alright, so this function, we're going to have get flow direction, and speed. And what you're going to do is you're going to pass in a world position. So we're going to pass in a vector. So we're going to have a position, and the outputs are going to be a direction and speed. Alright, so get direction and speed. So this class here, this water class, needs to interface this. So it'll be water surface object. And what we're going to need to do is actually implement this. Alright, so I'll be right back again. And in true independent game developer fashion, I'll be having a nice bowl of ramen. But I'll let that cool down before I burn myself on it. So we're going to need to look up into our actual object kind of all this. So we need a width and a height that's actually going to get saved. So we're going to need a map width, which is saved, which will be an integer. Width and height. I'm just going to say do not touch Alright, so this will be -1, and this will be -1. And we're going to need to actually save these, so we're going to need to grab the width and height. I mean, we can just actually get our height map resolution here and just set it. So that's good enough for me. But the reason I'm kind of splitting this off is one of them's saved, one of them's not saved, or whatever. But I'm just kind of throwing everything out here in case I need to do any shenaniganry later. I want to have them all disconnected. Because like one's actually used and is actually like saved data that I want as a post process, so I want to have it kind of separated from everything else that created it in case I ever change anything. I'll know that where the inputs and outputs of the system are. Alright, so we'll have a branch here, so we need to calculate the world position we need to calculate the texture position for the world position, and then from there we need to calculate the rest. So we're going to need to save some of this information. So we're going to save the information that we can use to calculate and convert from world space to texture space. And it's just like world to grid X and world to grid Y. And it's basically this value here. So we need the top left, top right, bottom left, bottom right set. And map width and height needs to be set as well. Alright, so I'm going to need to make a new function here called void setup map basic info. And so we're going to take in a const f vector reference. Let's see, top left, const f vector reference, top right, and we're going to take an int32 width and an int32 height. And then we'll also have a get map basic info function. So we'll do f vector. We can do outputs for references. So top left, f vector reference. Oh, it's bottom left. Bottom left and top right. And int32 ref width, int32 ref height. So we'll be able to snag this sort of basic info from here, and then we'll be able to pass this back into our object when we load it up, because we weren't able to actually save much information on this object. Alright, so bottom left equals m, bottom left, top right equals m top right, width equals m map dot m width, height equals m map dot m height. And to set this up, m bottom left equals bottom left, top right equals top right, m map dot m width equals width, and m map dot m height equals height. And then we'll be able to call this get grid square for world position. You're staying tuned. Do you want to see the result? Yeah, I want to see the result too. I'm working on it. But yeah, I want to see some objects floating around, and then I can like screw around with stuff. Alright, so we'll get our basic map info, and then this get grid square for world position will be something like this that we can pass in then. So I'm going to want to save this. I'm going to need two more vectors here. I'm going to need the bottom left and the top right. Alright, I'm also going to need inside of this construction script, I'm going to need a function which is going to be init bars. And what we're going to do is we're going to call on the flow field and do stuff. So let's go to our construction script. So we're going to need to call it right here. Alright, so you save this, close it, and then we'll be able to reopen, be able to build this thing, reopen, and then we can hook up the functions. So, alright. Let's save this information, set this information, and then we can actually call and use our information. So we need to, on our calculated flow field, we're going to need to get it. I need to call setup basic map info. So we're going to want the getters on all this. Alright, Calvin, thanks for sticking around. I'm sure you'll see more of this later. It's always kind of cool with, at least my stuff, I think. It's kind of fun to see some of the process and like the idea, and then there's like a whole bunch of crap in the middle where I actually do work. And then, so it's kind of fun, at least I think, the stuff of mine that would be interesting would be when I'm actually designing things, and then when it actually all works. And kind of this like magical box, you know, it's like, and then we do all this stuff, and then it actually works. Or the middle is just me, you know, just getting pissed off at stuff and complaining, getting hungry. So we got set up basic map info. We have got that done. Generate flow field. We are going to want to call get basic info, which is this function here. And then we're going to need to call set on a whole bunch of stuff. Alright, so width goes there, height goes here. So bottom left. Top right. Alright, so what we're going to need to do is we're going to call on our flow field get grid square for world position. Maybe I should just call get direction or something else on flow field. Let's just do it in blueprints to start with here. See, what is this going to return? It's just going to return the raw values, so they could be totally incorrect. Alright. So if So if this is less than 0, if this is less than 0, if this is greater than that, so we're going to want the get here, map width and height. So if it's greater than or equal to the map width or greater or equal to the map height, let's just do an OR. So Boolean OR. There we go. So if any of these are bad, then we don't need it. Otherwise, we'll compute it. And I need to eat this food. Alright, I think I can get back to work now, that I am not completely starving to death. Alright, so for calculating the grid square, we're going to want to grab the actual flow field data, which is a Dashkin storage object. How do we get something out of here? Alright, so it's going to be map width multiplied by the y value, and then we want to add the x to this and get this. So let's see, the other conditional that we'll want here is this variable length is greater than or equal to this value. So we'll kind of throw this right here. So split the structure. We split this structure as well. Alright, good. Alright, so I think that works properly. So we got like all of our checks to see like if this stuff actually exists, and then boom, we'll be able to do it. So I think we have the information that we need. So what we're going to want to do now is we're going to want to create an object which floats along this river sort of thing. So how are we going to do that? So get direction and speed. Do I know the guy? I do not know the guy. He made a game by himself in 365 days. Is that from Dust or? I'm guessing. I mean, there's plenty of examples of people doing all sorts of... Oh, the Elysian Tale one? Oh, the RPG sort of thing? Well, I mean... That's kind of what we're trying to do here with some of this. It's like a furry's wet dream. So many woodland creatures. And that's kind of part of the problem. Sometimes as an engineer you get so wrapped up in making a whole bunch of correct systems you don't make the game nearly as fast. Like I would say, without me, Adam would probably make the game faster, but it might not be as good. But the more people you get on a project, the longer it takes. He obviously had the skill to pull off every part of the development pipeline. Organization, art, business stuff, getting a publisher and all that, and then actually doing the engineering. So that's pretty cool. I mean, the other thing that was made by like one dude was the game Banished. If you ever saw that, like the guy like just went and built his own thing from the ground up. There's definitely people that are skilled enough to do that, do it all by themselves. I am a horrible artist, or at least I am an unpracticed person with artistry, so my art skills are garbage. Alright, so we have the return nodes, we have all these things. We need something that's going to try to fall in the world, and then it's going to have collision with something. So I mean, maybe we should just have a little ball or something. While we make a new test content, let's just call it floater. Make it an actor. We'll call it test floater. So what should we do with this guy? Should we throw like a flip hook in there? We'll use one of the characters, Fat Sack maybe? Use an animation for him. So we'll have like a little flip hook here for this guy. This guy is going to have him be environment body. So in our event tick for this guy, let's see, what do we want this thing to do? We want to grab everything that we're colliding with, or something like that. And we want to fall. You can't even draw stick figures. Ah, man, you'd be a terrible caveman. What's this? Sweep sphere. Target is Dashkin physics util. Sweep sphere in a direction? Yeah, okay. Let's see what we can do here. Alright, so sweep sphere in a direction. We're going to want to put this thing on the ground. Our direction is going to be down. Alright, let's do like a variable here. I'll have like current. I guess I need a velocity. We'll just do it from bare bones. Let's say we're going to want the size. Let's see, our radius, let's just have it be 100. Channel is going to be our environment body. And we're going to ignore ourselves. So get actor, get so we'll ignore ourselves. And we're gonna, I guess, yeah, we're gonna try to go in our velocity direction. Alright, so we tick this, velocity is gonna be this. So I'll do a ray trace straight down. Let's see. That variable, let's call it down. And that is -z. Do environment body. Ignore actors for the owner. Alright, so the first thing we want to do is see if there's anything below us. So we'll branch here, so if there's nothing below us, that's a sweep down, then we're going to add ourselves in the we're going to multiply our dt by, like, 10 or something, and then set our velocity to that value. Alright, so this will be fall and hit ground. So if there's nothing below us, if there is stuff below us, then we're going to sweep the sphere in this direction. Let's see, let's just set our velocity to yeah, it's easier to write this in frickin' code than it is to blueprint it out for some of these things. Because it's like I want to like set stuff and do other crap, and it's like I gotta drag all this crap around. Like I want to set you know, just the x and the y to 0 and then set the z to this other thing. It's just like, god damn it. Alright, so let's see. So we'll make a vector from the z and then add, you know, we'll go down. Alright, so this new thing will be a comment. This will be move on water. Alright, so we're going to go through our hits for this thing. And we're going to say we're going to get our wanted direction. Alright, so we're going to set our wanted dir to nothing at the beginning of this. This is so much easier to write in C++ than it is to deal with this crap. For just basic things like this where, well, it's not basic, it's just easier to deal with terse stuff than this. We want to see if this thing is a water thing, so it's like a water surface object. Ah, Christ. So we're gonna grab the actual actor. What is it? Time, location, hit actor. So cast to water object? No, it's not a water object. It's cast to test water. So if this is actual test water, then we want to get direction and speed. I'm going to add a new variable here that's kind of a convenience delta t value. So I'll set it at the beginning here. To make some of this not so awful. And I'm just going to throw this direction in here. I'm going to throw the speed in here as well. So we'll get delta t, we'll multiply by the speed we're supposed to have, and we will then set our distance to that. The position is going to be the get actor transform position. Alright, and let's output some stuff. This will be on water going in direction at speed blah. Alright, so if there was no collision, with the sweep, then what we're going to do is move ourselves to that. So we're going to say set actor location. I'm going to say, let's see, we're going to add vector. This will be our current location, and then this will be our multiply float by float. Not float by float. Multiply vector. This will be our direction multiplied by delta t. I don't know if that'll actually work the way that we want it to. No, I guess that's pretty much it. I guess it's vector times float. Yeah, that's what we want. So that'll be our new location. Alright, so we need to set our velocity and all that stuff. We need to actually set our position. God, this is so much just garbage in order to just move our object. Christ. Alright, so if we go to our test object, alright, well, let's construct all of our stuff here, ticket, and generate that flow field, save, exit, and then come back into this thing. Make sure we got everything rolling along properly. Alright, so the max width and all that, let's just close that out, save absolutely everything. But hopefully we can actually use that water now. Let's find out. Let's see, our bottom left, bottom right, all that sort of stuff is totally saved out, it looks like, and everything else like that. So if we hit play, we see this dude doing jack shit. Let's see, what is he even doing? What? Okay. Alright, so we're ray tracing and we're not hitting anything. I'm looking at the flow here and it looks like we're not hitting something, so we're trying to move on water and we're moving nowhere basically.